What's happening, guys? Welcome back to the show. Uh, we're still doing 1950s. This is part 2, by the way. Part 1 wasn't really much. We just got through one computer. So if you like this kind of content, hit the like, hit the subscription, subscribe to the channel, I should say, and hit that notification bell so you don't miss anything. Uh, if you get anybody wondering about the Apple MacBook 2008, don't worry, I haven't given up on that yet. I'm not going to give up on that. Uh, I think I don't know. I'll do some tests here shortly. Anyways, let's get to the history. So we read about the system info on Whirlwind. So we left off on the comments. So let's start at the bottom here. Wednesday, June 1st, 2011. Hobart Bellow, Florida, USA, says, I spent many years working on a Whirlwind computer, was an operator in tech. I see no mention of the original storage tubes before we get put in the core memories. Jeez. Also, you should talk about the 1800 relays the system had. It's a lot of relays. Monday, May 27th, 2013. Barbara Ullman from California, USA says, I have a question. I worked at Project Whirlwind as a secretary helper. Secretarial? I don't know. Something like that. A card puncher for two summers, 1953 and 1954. When I tell people this, they ask me how big the computer was. I told them the building filled a city block, but I'd like a more accurate size to tell my friends. My dad, Joseph Allman, wrote or edited the reports of the Project Whirlwind. I don't know why she posted 3 times, but moving on. Wednesday, March 19th, 2014. Ed from United Kingdom. Did he post a link? He did. What we got in here, guys? Okay. Cool. Cool. It's a museum. A genuine question, pardon the ignorance. Through the EDSAC, 1949, all Harwell Decatron, 1951, not classed as a real-time computer system. Neither of these were built as a replacement for a mechanical system. It's a good question. Let's look that up. So, let's look this one up first. Copy. Real time. I guess I can close that out. Is a real-time computer, right? Is that what you said? System. I want to say yes, since it's calculating. That's what it's meant to do, is calculate. So I'm gonna say that's real time. And let's look at this one, because this says right. What is that? Electronic delay storage automatic calculator. Uh, yes. This even says right here. The first successful general purpose computer arrived in 1949 in Cambridge. EDSAC, or Electronic Delay Storage Automatic Calculator. There we go. Good stuff. Now, let's just see about this one. So it's pretty much the same thing as what the EDA, the ADSAC is. Okay, so I will probably say yes to both. If you guys want to correct me on that, go ahead. Let's see. Oh, by the way, this is old-computers.com. If you guys want to go ahead and get on there and read it yourself, or just follow me. Oh, excuse me. I'll follow as I read, or what have you. You guys can. I'm going to pull up my chat. Alright, so last comment on this. Thursday, June 12th, 2014. John Ackley, United States, says World Run practically filled the 3-story Balta building on Mass Ave. Basement and power supplies. First floor, staff offices, drum storage system. Second floor, in mainframe, memory bank, control room. Third floor, NCRT input, output consoles. I don't know why they put money signs. It's weird. Roof, air handling to remove heat generated by 7,000 vacuum tubes, etc. about 170 kilowatts. Earlier computers in the US were basically glorified desk calculators. Whirlwind, I believe, was the first binary computer that followed Johnny von Neumann's proposal. Data and programs in the same storage unit. Also, first computer to connect via phone line to remote devices like systems, sites, and computers. Other than the memory test computer, built specifically, to test prototype core memory systems, Whirlwind was the first to use magnetic core memory. In the early 50s, Punched paper tape was the primary means on entering program source code. Whirlwind was followed by the TX0 and TX2 computers. Very nice. So let's check the TX0, I should say. Computer 0. What? Okay. There it is, right there. See that? Pictures right here. That's a good image. Very nice. Look at that. That's crazy. You guys imagine being in the 50s back in the day, trying to work on the thing like that. And look, right here. There's the paper tape puncher right here. That's for their data, to store their data. That's cool. That's really cool, guys. Look, there's a screen right here, right beside him. If you look on this side, this picture right here, you can see it better. That's cool. It's really cool. Alright, let's check 2. TX2. Looks about the same. Maybe a little bit bigger. Well, this all we got right here. Okay, cool. Alright. Let's go ahead and move on. So this was, what was this, 1951? Right? Yes, 1951. Univac 1 from Remington, Rand, 1951. Okay. Wow, look at that shit. I'm gonna zoom in on that. That's crazy, guys. Look at that. Look how big that motherfucker is. Damn. Okay. In 1951, the Eckert and Marchley Computer Company of Philadelphia delivered the Univac 1 Universal Automatic Computer to the U.S. Census Bureau. I think it's Census. It might be Kansas. No. Yeah. Yeah, I think it's Census. I don't know. Anyway, the machine was put into service on June 14th, 1951. It was retired on October 3rd, 1963 after 73,000 hours of operation. In the meantime, Remington Rand, now Unisys Corp, sold 45 Univac 1 machines to U.S. government agencies and private industry. Holy shit, that's awesome. And that's a lot of hours. 73,000 hours, damn. Let's see. What is 73,000 hours in a year. I don't think that's right. There we go. 8.33 years. So it ran a little more than 8 years. Cool. Good to know. Although it was not the first commercial computer, the why is that? There we go. The Ferranti Mark I was delivered a few months earlier. The UNIVAC 1 is considered the first modern digital computer and marked the real beginning of the computer industry. Wow. So this guy was he was like, hey, we're changing this whole ball game of computers. Okay, oh that's cool. For 5 years, this was the best large-scale computer in use for data processing. Technically, it was the first where the program and data were stored in the same memory space. Data and programs were fetched from memory, manipulated in registers, and results returned to memory. Every computer since the UNIVAC 1 has used some variations of that architecture. The beast was really imposing. It weighed more than 13 tons, held 5,200 vacuum tubes, and used 125 kilowatts of electricity. A simple addition instructions took about 100 microseconds, about 200,000 times slower than the Pentium 3. Wow. Yeah, everybody remembers Pentium 3. That wasn't really that good. Time for a divide instruction was of 3,600 microseconds. Large magnetic tape units and card puncher readers were used for data input, storage, and output. Results could also be printed on high-speed printer, 600 lines per minute. The first computer game was created on the UNIVAC. Wow. Okay. I didn't see this coming. It was called NIM and allowed humans to compete against the machine in a mathematical contest. In 1952, the UNIVAC also correctly predicted that Eisenhower would win the Eisenhower-Stevenson presidential race. Ooh. Okay. But the news media decided not to make the prediction public. Thanks to Andy Davis for the picture. Okay, that's cool. That's kind of creepy but cool. Okay, so let me see if William Hill's in the comments. William. No. No, he's not. Okay, so let's go back. Let's read what William says, reports. William F. Stegall reports, I was a junior engineer at Eckert Mutually, Computer Corp. My role in designing UNIVAC was small, but I did make a contribution to it. One clarification I would offer is that during the 1952 election, the program we ran to forecast the victor in the presidential election had Eisenhower as a winner as soon as the first few votes came in. Dramatic efforts were made to reduce the prediction of 100 to 1 for Eisenhower, but we never got the forecast below to 20 to 1. We had a wonderful fun doing our job. Damn. 100 to 1. Damn. Name. UNIVAC 1. Manufacturer. Remington Rand. Type. Professional computer. Origin. USA. Year. March 1951. End of production. Unknown. Built-in language. None. Keyboard. Binary control and ASCII keyboards. CPU. Vacuum tubes array. Speed 1,905 operations per second. RAM 1,000 words of 72 bits and delay lines. Size and weight 5. I think that's supposed to be 5. I don't know. 5, 25 weight. 5, 20. Yeah. 4, 25 weight. Width. Is it weight or width? No, width. 2.45 depth. 2.2.60 height. Meters. The commas throw me off. I really don't see comma in. I usually see decimals in that position, but anyway. Floor space. 943 cube feet. 13.1 tons. Wow. Damn, that's a big boy. Built-in media. Magnetic tapes. Price $750,000. FOB factory. High-speed line printer $185,000. God damn. That's a lot of fucking money for a computer. Shit. Alright, so we got emulators. You guys can go here and check it out if you want. I'm not going to, but I will open it up to see what it's about. Yeah, I'm not going to do that. El It looks like you had to pay for it. Let me click it. Let me let's see. The freeware version is complete except that it has no help information. Okay, but where's the freeware? Please get a new copy from Center if you have already registered. Okay. Oh, Page not found. Oops. Don't want to do that. Let's figure this out real quick. Let's go here. That page not found? No. A share well simulator both models 1 and 2. Yeah, we ain't doing that. I don't know, guys. It says it's freeware, but I don't see anything free about it. So, I mean, if you guys want to go ahead and pay for something that you're not sure what you're getting, all means. But I'm not going to do that. And I advise you guys not doing that either. So, let's see. Websites. See if these website works. Don't think that's right. Close out you. Computer Museum is down. My web page down. Okay, none of these web links works. Good enough. So let's go to documents, no documents. Let's go to comments. Some comments here. Monday, December 15th, 2003. USA says, how about an emulator for this thing? I don't think I had to find one on the sales forums, ducks. What's he ducking about? Okay, let's continue. But I'd like to see this old beast in action, even if it's only for a salary that weighs 2,600 times less and costs about 935 times less with a printer. Just think of case mod on one of these things, huh? Though, you could throw a huge BioWolf cluster in there on rack mounts. How quickly did the vac tube array run? I mean, could you measure that in hertz even? Also, how hot did the thing get? Were vacuum tubes hot or were they really cold? I mean, the heat output of high-end desktop CPUs has gone up as the process size has gone down. It's true. This is true. Email me with information. My email is backwards for spam protection. I'll munge it less if I ever get around to setting up my spam filter again. And has a .no spam on the end. Remove the .no spam and then reverse it. Huh? Anybody see an email? I don't see no email. Okay, dude. So, moving on. Wednesday, February 25th, 2004. Eric from PA says, I seriously think an emulator would work for this. Okay. Tuesday, October 26th, 2004. Daniel Saino from Switzerland says, there actually is an emulator for this machine, and UNIVAC 2. You can find it at shareware on Simtel. Just visit www.simtel.net and search different software. I'll try for UNIVAC, and you should be able to get it. It has been coded for one of the original UNIVAC programs. Okay, so let's try that out. I think this was the same website we went to, right, guys? Why not? No! It says, hell no. The website don't exist. Okay. Thursday, November 4th, 2004. David from Spain. About the question if the vacuum tubes were hot. Yes, a vacuum tube was a light tube. It had a filament that warmed up to 900 C, about 1650 Fahrenheit degrees when the thing was powered. It turned bright orange. In this way, the electrons could go from the cathode that was heated by the filament to an anode. By applying several hundreds of volts between them, by placing a grid between the anode and the cathode, you could control the intensity of the current at the anode by varying the voltage of the grid. In fact, the bulb of the vacuum tubes could get 50 to 60 C, about 120 to 140 Fahrenheit, less than the heat generated by a modern CPU, but if you add the heat produced by 5,000 tubes, the technicians shouldn't take it cold easily. Shouldn't take it cold? Sorry if my English is not very good. I have learned it by the public schools of Spain. Cool. Okay. Monday, March 28th, 2005. J4CK. I think it's Jack. Yeah. I don't know. You from US says, has anyone ported Linux to it? I don't think that's gonna work, man. Wednesday, August 3rd, 2005. Thinker from Germany says the UNIVAC was not the first commercial computer. The first commercial computer was the Zeus Z4 from 1950. Saturday, November 15th, 2008. Daniel from Switzerland, I think with the commercial computer they mean it was the first to be actually produced and marketed as a product that anyone could buy, anyone who could afford it. Remember, the Z4 was still a unique computer, of which only one was built. The UNIVAC was the first one to go into actual serial production. Okay. James Sanford. Well, this is on Saturday, October 2nd, 2010. James Sanford from United Kingdom says, I'd just like to say, this computer was not the first to store programs and data in the same memory. I would argue not the first modern digital computer. The small-scale experimental machine, also known as the baby of Manchester Mark I prototype, came online in 1948. The machine was the world's first stored-program computer and was built with the sole purpose of testing its cathode ray tube memory. Also, making this an earlier computer not to be built to replace a mechanical computer than the Whirlwind, the machine could hold 32 words of 32-bit length and had 7 instructions with subtraction but no addition. The machine had a typewriter for input, a cathode ray cathode? I don't know. Ray tube output, RAM, and accumulator, and an accumulator Anyway, so it had all the major components of a modern computer. I helped maintain a replica in the machine. Shit, can't talk, can't read apparently. I helped maintain a replica at the Museum of Science and Industry in Manchester in the UK. We are currently carrying out repairs on the machine, and an interesting offshoot of the current position is we have discovered we can run this valve machine, which fills a room off of a regular household plug. Really? Huh. Okay, so Thursday, November 3rd, 2011, computer. The first computer not commercial was the NEIAC. Okay, we're talking about commercial computers, not commercial computers. Okay, so Saturday, February 4th, 2012. Computer Guy, USA. Wasn't the first computer built in 1936? I'm not sure. Okay, Tuesday, July 21st, 2015. All this news, rich. United States. Picture of me taken for a magazine at Remington. Random Buffalo, New York. Picture is on my Facebook page. How do I get it to you? Okay, so he replies again the same day saying the same thing. Picture is of me operating the UNIVAC 1 in 1960 or 61. Alright. So that's done. 1951 is done. Let's check to see if they got anything for 52. Nothing 52. About 53. Nothing 53. 54. Nothing in 54. 55. Oh, the deuce. Alright, let's see. See how long we've been live so far, guys. About 40 minutes. 40 minutes into this. The Deuce by English Electric Company. Look at that, guys. That's crazy. Damn. The Deuce. Digital Electronic Universal Computer Engine was an oldish British computer manufactured by the English Electric Company in the 50s. From designs used by UK's National Physical Library, Library Laboratory (NPL) for the ACE pilot model automatic computing engine. Physically, the Deuce consisted of a cabin, roughly 10 by 8 by 6, which housed all the circuitry needed and had the console at one end. Still no transistors or printed circuit boards. It contained hundreds of thermonic, thermonic, something like that, valves in lines of 6-foot tall racks of circuitry. Huh. Okay. There were two kinds of storage. The high-speed store consisted of mercury delay lines and held 402 volts in all. There were 12 long delay lines holding 32 volts each and some short lines known as temporary stores, which held 1, 2, and 4 volts. The time taken for the contents of one delay line to circulate was called a major cycle. The time of one binary the words were all of the same length, 32 binary digits, about 10 decimal digits. Words were stored in the delay lines as a succession of pulses of 1 second per duration. Okay. A minor cycle was therefore 32 seconds. A major cycle was 1024 seconds, or just over 1 minute. What? No. 1 m dot second. Millisecond? 1 millisecond? All operations were performed in high-speed store. The secondary storage was a magnetic drum which holds 8,192 volts, disposed in 256 tracks of 32 volts each. The drum itself was a rapidly rotating cylinder coated with magnetic material. There were reading heads and writing heads to transfer information to and from high-speed store. A whole track was transferred with one instruction. Access to the drum was much slower than the high-speed store, and input and output were by means of conventional punched card equipment. Cards might be read at a rate of 200 per minute and punched at 100 cards per minute. 64 columns of a card were used by dose, which means that 24 words punched in binary can be read by one card. The console at the front of the machine had a bewildering array of keys and lights and two cathode ray monitor tubes. These tubes displayed the contents of the temporary stores in any selected delay line. Between 1953 and 1964, 33 machines were sold worldwide to various research and development establishments. All this information is courtesy of the Deuce website, which provides lots of information, lots of original information, photos, and testimonies about Deuce Computer. Okay, so let's check this website out. Oh no shit, look at that. It still works. Still there, guys. So if you guys want to come and check this out, it's right here. Still active. Goddamn. How about it? How about it? Okay, technical information. Name, Deuce. Manufacturer, English Electric Company. Type, professional computer. Origin, United Kingdom. Year, 1955. And the production, 1964. Building language, none. Keyboard, 32 key switches. CPU, 1450 Thormonic valves. Speed, 1 megahertz. Clock. Serial mode. Ooh. C code processor, none. RAM, 1.6 kilobytes. Acoustic memory, mercury memory. ROM, none. Text modes, 2 by 6 inch monochrome CLT. Size, weight, 14 feet. Width, 14 feet by 6 inches. Depth, 14 feet by 11 inches. Height, 92 square feet. 2,632 pounds. 1,193.85 kilograms. Building language. 80 column punch cards. 32 kilobyte magnetic drum. OS, none. Power supply, 440 volts. 3-phase, 50 hertz, AC, 9,000 watts, plus 300 volts, plus 200 volts, plus 100 volts, minus 100 volts, minus 200 volts, minus 300 volts, DC 6.3 volts, AC at 400 amps. Peripherals, 12 extra delay line, paper tape, I/O, magnetic tape. Price, 50,000 United Kingdom pounds. Okay, let's check these links out. Think we was here. Yeah, we wasn't here. Oh, damn, guys. Look, there's the instruction code. What? No way. Okay, now that's cool. Now that's cool. Can close you out. See what we got in here. Nope, nothing. Alright, let's go to documents. No documents. Let's go to comments. Monday, February 21st, 2005. Wilson Sam. Jeez. United Kingdom. Now, I don't know much about his computer. Whose computer? But I happen to know that Rolls-Royce plant in Bristol had 2 such units, as well as 2 KDF-9s that eventually sold the KDF-9s and replaced them with the PDP-10 units from Digital. Let's check the KDF-9. Oops. Oh no. Oh, what images? Oh, okay. Okay. Cool. That's cool. And then what's the other one? PDF? PDP-10. Oh, okay. That's cool. Look. Look, guys. Look at that. That's awesome. Awesome shit right there. Alright, so Wednesday, September 7th, 2005. John Barrett, Sydney, Australia says Bristol Sadly engines Patchway and Arbestra was later Rolls Royce. See? What? What you talking about, Willis? Let's see what this boy talking about. Okay. Okay. Okay, Wednesday, June 16th, 2010. The Deuce output drive from William Lindsay from UK. The Deuce output drive had 32 6CH power pentoids in the box. Just right for heating sausage rolls. A visiting royal searching for a comet and enjoying an aroma suggested we were cooking the results. Huh. Friday, June 9th, 2017, comma. Apparently this was a smaller version of Alan Turing's Ace because his colleagues thought that Ace was too ambitious, so they built the pilot model Ace, which ended up becoming the Deuce. Oh. Okay, well that's good to know. Saturday, December 7th, 2019. Audrey from Louisiana. I'm doing a social studies project and I picked the history of video games, so this was very helpful. Okay. Good stuff. So let's go back to 1955. And that was the last one for 55. Okay. 1956. 57. 58. IBM. Okay, let's look at these. Holy shit, that's a lot of comments. Okay. Well, yeah, I'm going to need another pop. I'll be right back. Stay. Stay. Alright, let's see where we're at now. Got 54 minutes into it. Alright. The ANFSQ7 from IBM. The ANFSQ7 was by far the largest computer ever built and is expected to hold that record It consisted of 2 complete World War II computers installed in 4-story buildings. See the impressive diagram and more pictures and picture sections. Alright, let's check out World War II real quick. So, was that all one computer? Because I see multiple of them back there. So, they might have multiple computers. Multiple IBM. I don't know. Let's check them out. Okay, so how the hell can they compare this guy with a computer that's L-shaped? Alright, I guess we're doing it. Each ANFSQ supported more than 100 users. IBM had about 60 employees at each site for round-the-clock maintenance, keeping one unit operating and one on hot standby to allow for switchover when vacuum tubes failed, resulted in better than 90% uptime. The results of the 2 units were reversed at a regular intervals, allowing diagnostics and maintenance to be carried out on the standby unit. There were usually several hundred tube failures each day, replaced by workers racing up and down our tube racks with shopping carts full of replacements. Automated tests ran by the computer itself would cycle the voltage to the tube racks down and back up to the induced marginal tubes to fail earlier, so that the computer would normally run correctly for the rest of the day. Without this process, the MTBF would have been a few minutes. Huh. Okay. By the time Sage was deployed, 22 or 23 stations in the period 1959 and 1963, sources disagree. It was nearly obsolete since it was designed to detect bombs. Holy shit. Okay. Not the new ICBMs. ICBMs? Okay. Nevertheless, it was operational until 1979 when the ROC, Regional Operations Control Centers, system took over using much higher speed computers. One Sage station continued operating until 1983, and this last unit was donated to the Boston Computing Museum since relocated to Moffett Field in Mountain View, California. The museum also has a tube panel for World War I, World War World War II, oh God, World War II consoles toned up in the TV series Battlestar Galactica. Oh, that's pretty cool. In spite of its limited military value, the Sage system served as an excellent prototype for an air traffic control system the FAA operated in its own ANFSQ-7 systems for the many years after Sage was shut down. IBM's experience with these systems has a great deal to do with its later success in computer systems and its dominance of the market for large computers. In the IBM 7090 was essentially a solid state version of the ANFSQ-78. The 7090 has its own rich history, including hosting the first ever multi-user APL system. So let's check out IBM 7090. And let's go to image. Oh, look at that, guys. Look at that little guy. Oh, look at that little guy. I mean, it's actually a big guy compared to what we got now, but... Oh, here we go. That's even better. Then look at that, guys. That's cool. That's really cool. Look at that tape, uh, fucking tape, jet. What do you call them? The tape puncher thingies that hold data back there. That's cool. Oh, here's a much better, clear picture. Okay, okay. Look, there's a guy back there changing out the tape stuff, the tape reels. All right, moving on. First CRT-based real-time user interface. First use of light gun to pick an item on the screen. Okay. First wide area modem communications, 1300 bps. First hot standby system for maximum uptime. First ground control of interceptor aircraft. The first inline microfilm fast-processed 35mm projection displays preceding parental polaris. A screen capture could be displayed within 30 seconds. First two-pass assembler permitting symbolic addresses. That's cool. That's cool. Thanks to Edward Charlin from Semputo Evangelist for this information. The photo from Mitra shows the rail panel wiring of SQ7 automatic element frame. Okay, so let's go to this website here. Sign in to be able to view. Okay. Oh, there's a picture of the guy right here. He playing on a laptop or something. He got MacBook sitting right down. Okay, so what's this guy here? Okay. Alright. Technical information. Name ANFSQ 7. Manufacturer IBM. Type Professional Computer. Origin USA. Year 1958. End of production 1963. Building language none. Keyboard IBM consoles. CPU 55,000 vacuum tubes in each unit. Speed 75 kips. 75 kips. Killer instructions per second. Coprocessor none. RAM Core 8892 World. ROM unknown. Text modes none. Graphics modes 256 by 256. Colors monochrome. Sound speaker, see the read more page. Size weight 2,000 square meters, 275 tons. I/O ports, tape, punched cards, modem. Building media tape, OS none. Power supply 3 megawatts. Damn. We ain't talking about watts anymore. We're talking about megawatts. Price $238 million, guys. printer around 200,000 to 250,000. Damn. Damn. That people had some money back then. Okay. System diagram. That's cool. That's cool. Alright. Okay. Links. Let's take a look at what this is. Yeah, why not? Not seeing. Okay. Okay. So one link works so far, and I'm gonna guess. Oh, 2 out of 4 link. Oh wow, look at that, guys. Okay. Oh, that's. Oh, that's the logic trainer and the poo board. Okay, that's cool. All right. Ah, oh, dude. What? Is this the... Oh, this is the fucking... Oh, no shit. No shit. Oh, that's cool. Okay. We gotta go through these pictures. Okay. That's cool, guys. Look at that. Look at that. Look at that. Look at that ham hock. Alright. Oh, there's the cabinet. It looks like it stores all the data over here. Up close. Command Post Console. IBM. Shit. Activate. Look at all those wires right there. Is that more wires here? Yeah. That's crazy, guys. This looks like a fucking AC unit sticking out. Damn. Yeah, there's a better picture of it. Look at that. Huh? That's cool. Alright, what else we got? Here we go. So, there was probably... well, I see 3 chairs. That's crazy. Yeah. That's cool. Any other more pictures? Haha! What the hell? Nice. Look at that. Alright. Look at that. Look at that. She's using the laser gun. That's sweet. That's sweet. Oh, that's sweet. Okay. That's sweet. Alright. Documents. No documents. Comments. We got a lot of comments to go through. So, February, October 15th, 2004. Linkman from Slavic Republic. Wow, that is a hard machine. Tell me how big disk space it has. Saturday, July 16th, 2005. From Clawhammer, UK. I would estimate around few kilobytes, as this big boy was created merely 2 years after the first HD was built by IBM. Excuse me. As such, uses FSQ7 magnetic core memory circuits instead. Even if IBM decided to include hard drives in the design, I seriously doubt the lowly cathode tube CPU would be fast enough to access data at an acceptable rate. Apart from this, IBM First HD, the IBM 305 RAMAC required 50 to 24-inch disks to store 5 megabytes of data, which would be prohibitively considering how much cramped the storage building was already. Hope this answers your question. Winkman, wink. So let's check the first HD from IBM. Let's check out some pictures of that. That. Actually, let me. There we go. Yeah, let's check that out. Images. Look at those. Look at those guys. Good God. He like, what you looking at, boy? What he got there? Is that a screwdriver? Oops. Is that a screwdriver? Oops. Is that a screwdriver he got? What you got there, sir? Need to see your license registration. So this was the first. This was the first computer with the hard drive. Damn. 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 Alright. Look, it even says RAMAC on it. That's cool. That's cool. Alright. Let's continue on. Tuesday, November 15th, 2005. Computer guy from garage. Probably from his garage. How fast was it anyway? How long did computers use cathode tubes for? Thursday, November 17th, 2005. Tommy Mason playing Halo on my pimped out 386. Cathode tubes were pretty much phased out around 1983. Although there was some talk about one still being fired up in New York for shift keeping, but I don't think that's true. Still, That would be neat to see. Oh. Wednesday, May 3rd, 2006. Alexi from Seattle, USA. So, can we get an emulator for this? I don't see it in mess. As for long-term storage, probably punch cards or paper tape. Maybe magnetic drum? Friday, August 24th, 2007. B from USA. To give some perspective, a $238 million computer in 1958 will be equivalent to $1.6 billion. $1.6 billion, guys. Computer today. Damn. Sunday, February 15th, 2009. Programmer learning TI Basic. A place, Country Road. I really wish there was an emulator for the IBM 305 REMEC. That would be a step in preserving the history of one of the mankind's most astounding achievements. The computer I myself love the REMEC. I myself love the REMEC's unique gray case. It rules. It rules. I want to own one someday, along with the Apple Pippin game system. Okay, so let's check the Apple Pippin out. Oh shit! It's actually a fucking game console? What? No. No. Really? Really? It's actually... No. What? What? Why do I not know this? Dude. Okay, dude. Okay. I need to see. Apple. I think I spelled that right. Oops. Ah, come on now. Let's copy that. Ah, no. Yeah, Amazon don't know what that fucking that. Like, I don't know what that is. Let's check eBay. See if we can find. See if we can find the Apple Pippin. No. Paste. What? No. No, dude. What? From Japan. Oh my god. Look. This one even got free shipping. What? No way, dude. No way. No way, dude. No way. Okay. See what games it had. Games. Okay. I don't read Japanese. I think this was a Japanese. Oh. Oh, what was this for? Was this for Apple Pippin? Wait a minute. Wait a minute. Hold up. Oh, okay. So, what is this for? Description. Android Apple Pippin. I'll be son of a bitch. I am lost of words right now. Okay. First off, let's go back. Let's close you out. Was Apple Pippin released in USA? Bandai originally planned to launch the Pippin in 1995, but the release was later pushed back to March 1996 for Japan and June 1996 for the US. The black color, okay, and it went on sale June 96. Okay, so we can get the United States version of it. Wow. That's great. I might have to do that one day, guys. But I don't know if I want to spend $600 on a game console. Fuck. Alright, continuing on. Friday, April 17th, 2009. Crystal Campbell, USA. The dates concerning the shutdown on the ANFS Q7 are not quite correct. I joined the Air Force in 1981 and I worked on the McChord computer until we shut it down and dismantled it. I did not actually arrive at McChord until after tech school, so the ANFS Q7 was definitely operational until 1982. I do not remember exactly when the mission switched over to computer replacing the Q7, but it would have been in 1983. I had heard that there was one still active in 1985, but I can't confirm that. It was a fascinating computer to work on. Monday, August 3rd, 2009. Pete. The article claims first ground control of interceptor aircraft. The Royal Air Force was doing ground control interception in late 1930s. It's largely this that allowed the Battle of Britain to be won, and hence German invasion prevented. Sage was extremely significant in many ways, but not this particular way. Huh. Very good. Tuesday, May 11th, 2019. Warrior Prentice. I was on a maintenance crew on a Q7 during 1971 and 72, and I never saw anyone running around with shopping cart full of tubes. The machine used pluggable units that were removed during the marginal checks and repaired on test bench. Saturday, April 9th, 2011. Paxton, California. I think that's supposed to say California. USA. I agree with Crystal Campbell. Sage was running in the Northwest USA. the 25th ADC until at least the end of '83. I worked at the other end of Sage at GATR site, ground to air transmitter receiver site, where we had the ANGK5 time division data link that the Q7 at McChord sent data to. The GKA5 then transmitted the data to the interceptors, coded messages that vectored the interceptors to their targets. The K5 was still running when I left the AF at the end of '83. For your information, I was stationed at the 777th Radar Squadron, Klamath, California. Peace. Okay, so let's check. Let's go ahead and check this guy out. Whoops. And I do believe that's probably an IBM too. No images? Images. There we go. Look at that. Look at that, guys. Damn. Damn. Look at that little phone right there. You guys remember those phones? Oh, I love those phones. I used to just play with them. Man, that's man, some good times. Okay, moving on. Tuesday, April 26, 2011. Tibet, U.S. Pete's comment on the first ground control of interceptor aircraft relies on a mixed metaphor, GCI, and the 30s was manual to pilot. Under Sage, it was actually controllable from ground. Same day, same guy. Questions on Q7 speed, memory, and storage. Of course, the Q7 was duplex, two independent machines interconnected. Speed, 2 MHz clock, 6 ms memory cycle time, 12 ms add time, 12 cycles. That's milliseconds. Memory, 64K killer. Okay. And 4K of 32-bit words, not bytes. Drums, 12 originally 6, with 6 fields each. Fields contain 2048 locations. Manuals are available at bitsavers.org, IBM Sage. Excuse me. The system was specialized enough that an emulator would do you no good. It was never used in a data processing environment. Okay. So, let's check. Let's check you out. Oh shit. Let's check. Nope. Not found. Sunday, January 1st, 2012. Steve from Vermont. I worked at the 24th NORAD site at Malmstrom AFB, Great Falls, Montana, from March 1981 to June 1983. When we shut it down and locked the door, I was the tech that worked on the TDDL, time division data link system, that the computer communicated through to the guard jets. I worked in the computer repair lab as well. Sunday, May 20th, 2012. Dean, Florida, from Florida, USA. I went to tech school at Kieslow, AFB, in 1964 and 65. A 49-week basic electronics course and advanced training on the ANFSQ 7. In August 1965, I arrived at McChord AFB as a computer maintenance tech. I worked on the computer for 2 years. At that time, there was a direction center, DC, and the command center, CC, co-located in the same building. In 1966, one of the computers, I think the CC, was shut down and sold for scrap. I helped remove the equipment racks and consoles in the later years on the TV show called The Time Tunnel, had one of the main computer control consoles to control the time tunnel. Another TV show called 20,000 Leagues Under the Sea had one of the drum control panels as a control panel on the submarine. I left the vacuum tube computer in 1966 and was assigned to Transysist version called Backup Intercept Control Buck Buick. The new computer was a backup to the Q7, but with all the same plus increased capabilities in much smaller package. It was housed in the building of 4 or 5,000 SF on a raised floor with cabling underneath the floor. After a few months of QJT on the new computer, it was transferred to Udon, RTAFB, Thailand, in 1967 to work on the Buick, which was used to control and direct fighters and bombers flying from Thailand and South Vietnam in the Vietnam War. I'll be happy to correspond with anyone with the ANFSQ-7 in my experiences. I'll be right back. Sababa, what are you doing? What are you doing? What are you doing? What are you doing? Jojo, where you at? Daniel. Daniel. Stay. Okay, I'm back. So where we at? Jail, stay. Monday, November 19th, 2012. McLamo from Oklahoma, USA. This is for Dean from Florida. My experience was parallel yours. My experience parallel yours. I graduated Keyslow and reported to Q7 shop at Topsham AFS, Maine in September 65. That means we were in Brine Hall at the same time. Stayed at Topsham until 1968. Went to UDorn when I worked on the UNIVAC 1052 base supply computer. Came back to the States on SACS for 650L system. Worked on it until 1982. Went to tinker on the airborne computer tech on the E3 EWASCs SCS aircraft. Stayed with that until 1994, in which time I had 30 years service and retired. Okay, so let's check out the UNIVAC 1052. 1052. Oops. Yeah, there we go. Images. Look at that. Look at that, guys. Look at look at that, guys. That's sweet. All the switches there. Air Force Logic's automation. That's nice. Look how small that is compared to everything else. Look how much smaller that it was compared to the original UNIVAC. That's crazy. Okay, let's go back. Let's check out the SACS 465L. Images. Wow. Dude, they got beds back there too. You see that? I think that's a bed. That's crazy. Then let's do the E3. That's no plane. Okay. So, Monday, May 13th, 2013. William Lagaz from Richmond, Virginia says, "My father, Conrad, was assigned as Tomsham AFS from 62 to 69, working on the ANFS Q7 Sage. Still knows a great deal about the system. Anybody who was there, then please let me know." Alright, Tuesday, October 22nd, 2013. Dave Bignoli, Phoenix, Arizona, says, Went to Keyslow AFB to BD, Basic Electronic Development, and was coded in a triangle area May 1962 to 1963. Worked as a central computer tech at McGuire AFB, New Jersey through February 1966. There were not very many central computer techs around. We just had four at McGuire. Went to work for the GE upon discharge as a field engineer through 1970, and then got out of the field and into the real estate in the Phoenix area. In 1973, decided computers and real estate was something that needed to each other. Currently operate a system that elevates real estate. www.popularvaluecentral.com. The AF provided me with great living my entire working life. Let's go check this dude's website out. Oh, no shit. Look at that. Alright. Cool. Was that you? Tuesday, November 7th. Thursday, November 7th, 2013. Mark Avant from Yucapa, Carolina. Or California, one of the two. I was a crew chef for a maintenance crew on the Q7 at Fort Lee, Virginia from 1979 to 1982. We called the Coral Stacks Big Memory and Little Memory. A couple of years before I arrived, they had a fire up in the weapons area. Oh shit. Soaked the entire computer. We used to have issues with the wire relays all the time, taking them apart, cleaning them with an eraser, and voila! Problem solved. Troubleshooting with oscilloscope, and logic diagrams. Those were the days. After I left the Air Force, I worked as a field engineer for Wong Laboratories and then went on to network administrator after the collapse of the mini computer industry. I am retiring in 8 months from my current position as a network administrator for a school district. No more banging my head against a virtual wall. Damn, congrats, bro. Tuesday, February 18th, 2014. Bill Ramsdale from Trucks AFB Madison, Wisconsin. I do believe that's Wisconsin. Oh, maybe it's Washington. No, I don't know. Just out of high school, I was hired as a multi-list operator at Trucks AFB Air Force Base in Madison, Wisconsin. Ooh, I was right. I was given a confidential security clearance. About 1950, I was promoted to process the programmer's programs into computer VIA, punch cards, and return the results of their efforts to the programmers. I was employed by the Systems Development Corporation, a division of Rand Corporation. I've also, in my clearance, changed to secret. I worked at this position for about a year and a half until the Air Force took control of the facility. Sunday, March 2nd, 2014. Jim Bella, Oregon, USA. I was a computer maintenance at Adao AFS Oregon from 1965 to 1968. Started out as a display, cross-trained to central computer later, and about 1967, some genius decided we should change all the Raytheon 5616 to 5818 tubes, which were the meat of the computer. We protested, but had to do it anyway. About 5 on the new ones were bad. Had a heck of a time getting it back up. They closed Adar July 1969. Damn. Whew. We're about there, guys. A little halfway. See where we at now. About 2 hours into it. Tuesday, May 27th, 2014. Dr. Dave Felsberg, USA. Excuse me. I served as a maintenance technician, crew chief, and site trainer at Fort Lee AFS, Virginia, Washington, Air Division Sector, WADS from 1967 to 1969. The Q7 provided one of the best basic computer operations and narrow civilization mission training available anywhere in its maintenance console, hosting over 10,000 neon lights. Allowed technicians to single-step through machine operations to which data transfers and troubleshoot with ease. Its size was equivalent to 23 ranch-style home with an internal telephone system to match. It had 123 miles of internal signal wire and 75,000 vacuum tubes. It was so impressive that the Hollywood bought several of the surplus machines as they were shut down or never installed. They were featured as in Lost in Space, Journey to the Bottom of the Sea, Time Tunnel, and many more. The expertise I gained at Fort Lee made it easy to become site computer maintenance trainer for Ardent at Clark AFB, RPI, and complete in the electronics engineering degree. As an officer, I led a special team out of the 4754th Radar Evaluation Square at Hill AFB UT to respond to a disabling a fire in Fort Lee Q7 by redirecting all air civilization inputs and response capabilities to 2 neighboring direction centers. The severely limited data handling capacity was adjusted by focusing computer processing on only those aircraft of interest instead of entire civilian air traffic load. The basics of the computer operations and maintenance learned at Fort Lee led me into over 20 years of active USAF time in computer systems design and engineering, climating with 4 years as at the USAF academic leading in mathematics department and teaching engineering application to thousands of academic candidates. I have always been grateful to the knowledge and experience I learned through that old vacuum tube computer. Okay. Thursday, August 28, 2014. Gary Cartwright. I was hired by IBM in 1958 to help install and maintain the NFS Q7 at DC-13 at KI Soil AFB outside of Marquardt, Mich. But by that time, the Sage semi-automatic ground environment systems were being installed in 3-story buildings. The computer was amazing compared to what we have today. What we call RAM today was 64K core memory unit. That was the big memory retrofit, and the original was 4K. I was part of the maintenance team until the USAF Operation Blue Suit, which turned over maintenance to Air Force personnel. I stayed on as a contract technical services until the site was closed in 1963. It was the basis for my continued career in IBM and commercial field service, eventually programming support, engineering, and finally product pricing before I retired. Since then, I have built PCs as a hobby. Sage was the great beginning of that career. Nice. Wednesday, December 17, 2014. Mike Parzell, USA. I joined IBM right out of the Navy in 1957 and trained on the Sage computer in Kingston, New York. Our team installed the system at McCall AFB in Tacoma, Washington. I recall during the installation that the air conditioning system was being tested and I do believe room temperature was around 50 degrees. Wow, that's pretty cold. And this was in the summer. In fact, I received several cash awards for changes to the 026 card punch menu installation. Sunday, April 26, 2015. Richard Haskell, USA. I was a USAF trained at Kiesel AFB 665 to 666 on the QC. First permanent party station at McGuire AFB NYADS as a 3553A, then Topsham AFS BODS. While at McGuire, I was awarded Airman of the Year and had my photos taken on the job. These are some of the best and most detailed photos of the Q7. Contact me at the listed email for copies. Then he replies back again the same day. Listed email. I'm not against. No. We ain't doing that. Saturday, November 28, 2015. Glen Crandall, Atlanta, Georgia. There were usually several hundred tube failures each day, replaced by workers racing up and down the racks with shopping carts for replacements. This statement is incorrect because the automators conducted on daily schedule actually failures was extremely rare. The only time large numbers of tubes were replaced or occurred happened after 4 hours of operation. At this time, predicted failure rates of vacuum tubes rose to the point where all tubes were replaced. Usually about 100 to 200 tubes were replaced at a time during the phase. I joined IBM in September 1957 and went to Kingston, New York for 6 months training period. My permanent duty assignment was the DC at Gunter, AFB Montgomery, Alabama. I was there for April 1953 to November 1961. In November 1961, I transferred to the software development site in Santa Monica, California. I was there until June 1966. Almost there, guys. I told you there's a lot of fucking comments. Shit. Thursday, August 18th, 2016. Jeff Davis, USA. I worked on the Q7 forum from 1974 to 76 IO and displays at Duluth, Minnesota. Was a lot of fun to work on. Had big and little memory drums, reel-to-reel tape, card reader, printer, used relays. Lots of them would boot up using plugboard, if I recall the name. The display console had 10,000 volt power supply that had to be checked during maintenance. You have to turn off the power, attach your probes, and then turn power on. If you attach the probes before powering off, the jolt would knock you back on your butt or worse. Damn. Toughest problem I worked on was the intermittent failure that we finally found by turning off the lights where the frames was with pus and looked for bad tubes. We found a culprit. One blue tube. The other cool thing was that there was a speaker that would emit these squeak-like sounds while the main program activate mode was running. It was the same sound pattern over and over, so you could tell by listening if things were running okay. You also would know when things were going down. Then the commander would call down from the 4th floor over the loudspeaker. Hee hee. Fun times. Tuesday, November 8th, 2016. Whole people, I think, maybe it's FIFO, Hope FIFO. I attended Q7 training at Belloc's AFB in 1967 to 1968, but was never assigned to Q7 site. Instead, I was assigned to the NORAD Cave and later to the Buick site at the Havel AFS. An interesting observation about Q7 was its extremely high reliability due to marginal testing of the backup system. The tubes were subjected to over and under voltage stresses. Excuse me. Vacuum tubes that would have failed during normal operations were pre-failed junior stay on backup tube systems rather than being allowed to fail during critical online operation. As you might imagine, imaging, the building housing the Q7 required only air conditioning but not heat, as this was provided by over 100,000 vacuum tubes. Damn. Same person, same day. Obviously, it was the Keysore AFB, Battle Axe, Mississippi. Okay. Whew. Wednesday, July 18th, 2018. Keith Kyrie, Pittsburgh, PA, went to Keysore for SAC HQ training, but got assigned to Duluth from 1972 to 1975. Enjoyed the computer maintenance career, 30,594. Spent 34 years and retired as chief at Duluth. The shop manager was a civilian. He used to come to at night to drive us crazy, installing faults and making us troubleshoot them. Anyone remember 4CV was the main clock. Tuesday, August 21st, 2018. Michael Yashall. I trained as a communications computer systems analyst at Keesler AFB in 1965. We had a field trip to Q7 in Montgomery where we each wrote in Java and ran a small program on the backup system. The CLT Light pen programming was fun. For some reason, we thought that NIFA economy, or whatever, how you want to say it, was hilarious. Not in file area. A flip-flop that was activated by a light reflecting on a piece of aluminum foil glued on the magnetic tape near the end of the reel. Anomaly? I don't know. Monday, February 4th, 2019. Gary Nelson, United States. I was the first generation USAF Blue Suit. Graduate of the IBM Kingston Training Program in 1961. My job code was 30,551. I was a computer repairman and later computer operator of the Q7 at Duluth Aero Division Sector Dudes. One topic I have not seen mentioned was the fact that many of the voltages that ran the computer came from the motor generators that were controlled by the computer itself. The pentode tubes was designed so that when run at lower or higher than the normal voltage, they would fail. By this means, the failure rate of 48,000 tube system could be acceptably low. Saturday, February 20th, 2021. Fred Pinto, United States, taught the NFSK 7. Brian Hall, KFB, early 60s. Good for you, Fred. Monday, August 23rd, 2021. Henry Spencer, United States. I programmed the NFSQ7 computer to play music in full-part harmony. I was a student in the USAF Command and Control Computer Programming course at Keesler AFB in Mississippi in 1965. I was a second lieutenant at the time, later becoming an instructor. I have a recording of 4 pieces of music I programmed that we played at Montgomery Air Division Sector site in Mobile, Alabama in 1965. I can send you a copy of music if you email me requesting it. I'm not going to say your email. I had heard some previously written tunes that had been written with 1 and 2 parts. I speculated that if played at the proper speed, I could program an accumulator bit to repeat 4 notes of the chart to simulate 4-part harmony. I wrote a test program to do that. After I picked the proper speed, I then programmed these 4 pieces of music. I don't understand why people want to just put their emails out like that. I wouldn't have done that. Like, no. That's a good way to get hacked and bad shit. No. Anyways, we got two more comments, guys, and we're done. Wednesday, December 15th, 2021. Jacob Coleman, United States. Unfortunately, my own father's experience directly contracted Glenn Crandall's statement. He absolutely witnessed people running up and down aisles of tubes, replacing them with shopping carts while he was an operator on ANFSQ7 Michigan. My assumption is that the load they were under simply wasn't enough to trigger that many failures because they deliberately induced them twice a day and still managed to need people running up and down in the aisles, replacing them. Sunday, June 17, 2022. Richard Wayne, United States. I joined IBM in Kingston in 1959, and after 20 weeks of training, I was assigned to Duluth ADS Sage location as a central computer field engineer. I was there for 5 years. I never saw anyone racing though the aisles with replacement pluggable units (PUs), nor did I witness large numbers of tubes failing daily. Most of the tubes was in the pluggable units were replaced in the PU lab. A great time. All right. Whew, okay. 1958 IBM. There you have it. Let me check 1959. Nothing. Alright, guys, that is it. We are done with the 1950s. If you guys know any other websites I can go to that has more computers and more information on these computers that is 1950s, before I start the 1960s, let me know. But oh, and just put it in the comments or whatever, or leave it in the live chat if I'm still live, which I'm not gonna be live too much longer. I'm about to jump off of here. It was a good 2 hours and 10 minutes live stream, so I'm happy with that. Yeah, yeah, this was pretty cool. If you guys like this kind of content, let me know in the comments. Hit that subscribe button, hit that notification bell so you don't miss anything. And hopefully by this week or this weekend, I will have the MacBook up and running again. And yeah, stay tuned for that.